Welcome back to a course on campus for several variables. In this lecture, we are going to talk about the concept called implicit differentiation. Yes, of course, we have introduced what do we mean by implicit differentiation, and we have seen a problem based on it. So, what till now, that is in the previous one or two lectures, we have been discussing about the concept of chain rule. Does this chain rule has anything to do with this implicit differentiation? Yes, of course. Whenever you are, what was the idea behind the implicit differentiation? Suppose y is a function of x. Instead of giving y explicitly as a function of x, we may be given some function involves both the variables. Okay, we may be given with some equation which involves both the variables. From this, we will have to deduce what is dy upon dt. Sorry, dy upon dx. So from this, we will have to identify what this quantity is. Here in childhood, that is, we are given some function of x and y, where x is a function of t and y is also a function of t. So in this case, what do we find? We find dz upon dt as del z upon del x multiplied with dx upon dt plus del z upon del y multiplied with dy upon dt. So this is the ideology through which we do things, right? If you look at here, you are transferring this function involves two variables into a function involves only one variable. That is why you have this quantity. Okay, that is dz upon dz. So these are similar. Actually, they are same. The notations that we give is different. We don't need to worry about the notations. We have to just focus on the ideology behind it. So, whenever, okay, let me give you a problem so that you can identify what it is. Right? Suppose, okay, let me work out a problem and then let me go to things. Explain to you the ideology. Find dy upon dx if y square minus x square minus sin xy equals 0. So this is the thing that we have. So from this, what should we find? We'll have to find dy upon dx. Okay. So how are we going to do? We know that if we differentiate this one with respect to x, we are going to have 2y times of dy upon dx minus x square, sorry, 2x minus, so this shall be differentiated as cos xy. And what should you do? You have to differentiate this quantity, and this would give you having x as it is and differentiating this one, then having y as it is and differentiating one, and is equated to 0. Now, if you combine all the terms involving dy upon dx together, so dy upon dx minus cos xy x multiplied with dy upon dx, and take the rest of the terms to the other side. So it is going to be 2x and plus y cos xy. So from which you can write your dy upon dx as 2x plus y cos xy upon 2y minus x cos xy. So this is how we do the implicit differentiation, right? Okay. Now the easy idea is to dy upon dx is fy upon, sorry, minus fx upon fy. If you are given a function, be careful. So if this is your function, then you may write this way. This is the idealization. So comparing these two, we shall write this one. Okay, so suppose this is given. You are asked to differentiate with respect to y. So what will you do? Sorry, with respect to x. So what would we do? F prime, okay, f prime of x y, and then the derivative of x is going to be 1, okay, plus f prime of x y and the derivative with respect to this one. So what are these two? So here you are going to get one only when you differentiate with respect to x and just equate it to 0. So from this, your dy upon dx is going to be here. What you actually done is you have differentiated with respect to x and here you have differentiated with respect to y. But y is a function of x. That is why you are making, actually you are making use of chain rule here. This involves two functions. Okay, x is a function of x itself and y is a function of x. So whenever you differentiate this one, partially differentiate with respect to x and the derivative of x with respect to x, and that is going to be 1. Okay, and partial derivative of this one with respect to y and derivative of y with respect to x. That gives you this one. So from this, if you write it, your minus fx upon fy. Now, let us see whether this works perfectly fine with this or not. Okay, so for this problem, let me find out what is fx. That is, you have to take this entire function as a function of xy, that is big F, and differentiate this one partially with respect to x. So you are going to get minus 2x minus cos xy multiplied with y. Okay, and your fy is going to be 2y. Remember, you are treating x and y are independent variables and you are performing the partial differentiation only. So it is going to be 2y minus cos xy multiplied with, you will have x. So if you write minus fx upon fy, it is going to be minus times of this one. So when you take minus out from the numerator, you get the same quantity. Right? Instead of coming this way, you may go this way. This happened due to the chain rule and partial differentiation. So hope you have got the ideology behind it. Now, of course, the ideology can be extended for any number of variables. Sometimes you may be given a function of three variables and you may be asked to find out any of the derivatives. When you are given like this, okay, from which your partial derivative may be asked. That is del z upon del x or del z upon del y may be asked. Now I shall give you an example. So just a minute. The textbook that we are following does not provide any example problem for this kind. Let me see if we have anything in the yeah, we have something in the exercise. So let me go over that. Is it q minus xy plus yz plus yq minus 2 equals 0. Okay, you will have to find out the this is given. You will have to find del z upon del x and del z upon del y at the point 1 comma 1 comma 1. So let us see how to proceed with this. Okay, let me erase off this part as well. So if you wish to go by the traditional way, we can do. First, let me show you the traditional way. Let z cube minus xy. Okay, let us take this as a function of xyz. Z cube minus xy plus yz plus y cube minus 2 equals 0. Right? Let us now differentiate this one partially with respect to x. Differentiate one partially with respect to x. So you would get 3z square del z upon del x. And here you would have y. Here z inverse x. Remember, here your z is a function of x and y. Okay, so you will have to treat that way, and so here y is going to be there, and you will have del z upon del x. And here when you differentiate y with respect to x, it is 0, and the derivative of 2 is again 0. So this is what you are having, and is equated to 0. Now if you take the terms which involves del z upon del x, so this is what you are going to have, and minus y when it is taken to the next step, you will have this as y. Therefore, your del z upon del x is going to be y upon 3z square plus y. Okay. Now, recall what we have seen in the previous problem. That is, if it is a function of two variables only, so dy upon dx is minus fx upon fy. Okay. Here, what are we trying to calculate? We are trying to calculate del z upon del x. So it is going to be minus fx upon fz. If you find what is fx and what is fz from this, so when you are trying to proceed by this way, you will have to treat x, y, z. All these are independent. Try that way. So your fx is going to be z is to be treated as a constant by your differentiate with respect to x in this way. So you are going to have minus y and only minus y, and your fz is going to be 3z square plus y. So if you give your del z upon del x is going to be minus times of fx, so minus of minus y becomes y upon 3z square plus y. Right? We are getting the same thing. So it is easy to find del z upon del y, which is minus fy upon fz. Let me do by the second way, as you know how to proceed with the first way. So here your fy is minus x plus z plus 3y square, and your fz is again 3z square plus y. So del z upon del y is going to be minus times of this, therefore it becomes x minus z minus 3y square upon 3z square plus y. Now we are asked to calculate these two derivatives at the point 1 comma 1 comma 1. Therefore, your del z upon del x at 1 comma 1 comma 1 is 1 upon 3 times of 1 square plus 1. So it is 1 upon 4. And del z upon del y at the point 1 comma 1 comma 1 is 1 minus 1 minus 3 multiplied with 1 square upon 3 1 square plus 1. So it's going to be minus 3 upon 4. That's it. Thank you.